Hi, welcome to the 6502 show. Today, we're going to talk about data. How to get it into a program when the language you're writing the program in doesn't have read or data. In order to get our data into comments, we first have to understand how the lines of code are structured in VTL2C and Tiny Basic. VTL2C, you can see that every line starts with a line number. In this case, it is line number 10, lower ordered byte first. Then the number of line elements are listed, including both the line number and the end of record number. That's 21. So then your data is wedged in between there. And let's just say that you have these pieces of data here. The closed parenthesis is the marker for a comment in VTL2C. We have a space, and then we have some ASCII. Next up, Tiny Basic, a little bit different. You do have the same line number at the beginning, line number 10, and in the same format, but then it goes right into the data. So whatever is going to be in that line, that's what's there in ASCII. You have an REM, and I threw in an asterisk simply because it's something I can check for later. I don't have to. It could be a different character. Doesn't matter, really. And then I got my data and an end of record marker, which in this case is 0D, a carriage return. Now, armed with that knowledge, we can move on to actually using REM statements or comments in our programs as data. Okay, let's go over the Tiny Basic code line by line. We have a remark in which we are going to stash our numerical data, 2 digits each, 10 elements. This is the array address where we're going to put stuff that is Riot RAM in a PAL1, MicroKim, or Kim1. In Tiny Basic, this is the address we called peek, this is the address we called poke, and this is the address of that REM statement. This is where it's going to start. Decimal 2822 is that right there. And we know that because we can refer back to our chart. We got some loop, pointers here, counters. And now we get into the nitty-gritty. We are going to use the user statement to peek into that REM statement up there, character by character. And the first one we know, since there are 2 digits, it's the tens column. So we go and get it, and it ends up in Q. We subtract 48 from the ASCII value to get the actual value of the number. Then, because it's the tens column, we'll multiply by 10, advance the counter, we'll peek again, but this time we're going to put it in variable z, and that's the ones column, so all we do is subtract 48 from it to get a numerical value, add the 2 together, and then, bam, we poke it into our array, plus j, and the q value is what's going to go in there. We advance our counters, and we go do it again. To print it out, we'll use this right here. We'll just peek those addresses, print them out, and go through the loop. That's it. And down here, we have the equivalent in Microsoft Basic. So as you can see, we've got reading, and we're reading data, and we're sticking in an array. Pretty good. Okay, we've got Tiny Basic up and running, and let's get a listing of our program here. And we will just give it a run. We're going to read in that data and poke it somewheres. and then have it in an array that we will print out at the end. And there you have it. Read it in. And let's see if I remember how to do this. I think it's commas. Sure enough. And there's our data in the rem statement, and our results were up top. Excellent. Unlike TinyBasic, VTL2C does not have built-in peek and poke code, so we have to supply some ourselves. Here's a little bit that I just hacked together. It's maybe not great. I'm sure someone could do better, but it works. Right here's our poke code, and we're going to use a couple places in zero page to store addresses. And we have two sections for poke. This first part is storing the address to which we want to poke, and then the second part actually puts whatever we send it into that address. Here's how you use it in VTL2C. We set up the address of the poke routine, and then we pass the address to it. This is going to end up in string 10 and 11. Second part is we call the second part, address of store value, and then the value that we want to send. You can send 16-bit numbers, but let's just keep it simple. And how often are you going to want to poke a value greater than 255 anyway? Here's the other end of the story, peek. And here we call it at that address. And that's the address we want to peek that we pass along. And what happens is the return value is put into, it looks like B6, B7, just some random stuff. This is actually the variable open bracket and the square bracket. And that is a usable variable in VTL2C. And that way we'll be able to use it within our VTL2C program. Here is the VTL2C code that we are going to run. And you can see that the brackets, both open and closed, are used as just simple variables. It does make it kind of hard to read, but you get used to it. Kind of like anything, I suppose. Like when you were eating cauliflower as a kid, it's like, well, I guess I'll get used to it. It's very much like the TinyBasic code. In fact, it's almost identical. You're multiplying by 10 the first digit, and then you're just getting the next digit. We're scraping off the ASCII value to get the numerical values, and then we'll just go around until we hit every data element. And then at line 200, we'll start printing out the array. VTL2 has an array. We'll just go through and print out the sequence right there that we'd read in previously. All right, we have VTL2C up and running. Let's take a look at the program that I've loaded. This is essentially the exact same program as the TinyBasic example. Let's give it a run. Pretty darn fast, a lot faster than TinyBasic. But there you have it. Those were all poked into the array. Let's see if I can print, let's say, into the array. I want to look at the fourth element. So we'll print it. Sure enough, there it is, the fourth one. Print equals the sixth element, 66, as it says. Now we're going to save some data in Focal 65, and I'm going to go through this line by line and probably element by element, just simply because I'm sure not too many people are familiar with the Focal language. First thing we're going to do is we're going to set up the size of our string. Basically, we're dimensioning it to be 22 pieces of data long. And Focal will default to 72, and 72 characters is a lot, and if you had a lot of strings, you could really start eating up your valuable RAM. So we're going to pre-dimension this thing. This next set command here this tells Focal that we want to output to a device rather than our console. And the device we're going to cleverly output to is a string. And we're simply going to type the string we want, use the type command or print, and this will stick that string into a string. We'll reset our output to go back to the console, and now we'll set our input to be a string. So where we're going to take any input from, not the keyboard, not some disk drive or tape drive, we're going to take it from the string itself. This is a for next loop. We're going to go 1 to 11. And this is essentially assigning the variable x with a single key press. But instead of a key press, it's going to be coming out of the string. We'll subtract 48 to get the numerical value from the ASCII value, multiply by 10. And look, we're already setting up our array here. Arrays don't have to be defined in Focal, numerical arrays. We're going to get another character. That's our ones column. We'll take the ASCII out of that, and then we will add it to our array element. And when we're done with all of that work there, we will reset the input device. And this is our little printed out program right here. We've got a little for next loop, 1 to 11. This sets up a 2-digit printing response. And then we'll print out our the name of our variable and then the variable itself. All right, let's give our little Focal demonstration program a run. Never mind the garbage there on the screen. When Focal loads, sometimes there's some just junk in its text area, so it spits it out, but we can issue a W command, which is a listing, and there's nothing in there. So let's put something in there. All right, we've got stuff loaded, and here's what our program looks like. We list it, and let's give it a run. Yeah, that's the data, and there's the output, and everything is in its variable. And I can print out a variable table to show you exactly what we have here. Type the table. Yeah, exactly the same as our output. So there you have it, folks. Focal, ability to put numerical data inside your program. Okay, let's take a look at the embedded data portion of this program. On the left, we have Microsoft Basic, Kim 1 Basic 9. And that is cut and dried, folks. A little for next loop, read some data, stick it in an array, and we're done. To do the same thing without read and data statements, we will start right here at 800 on the other side. Yeah, it's a little crazy. We're building these big strings. They can be no bigger than 255 characters because the buffer won't take any more than that. But as you can see, we're going to have to do some calculations. Now, these are uniform pieces of data. They all have to be exactly the same length, each element. And in this case, that element is 3 digits. Down here is where we're going to do the work of converting what we read, we get from our strings and parsing those into individual chunks of data. And we've got some comparisons going on here. And this line is actually kind of interesting. In fact, it's the only interesting thing about this. Otherwise, it's just straight ahead, get something converted into something else and stick it away in a variable. Apple I Basic does not allow the direct comparison of multi-subscripted string variables. So, I can't compare Z string to X string. Instead, I will take that element, stick it into another string, and compare those. Cumbersome? Yeah. But this is one way to have embedded data in your program and have it all work. Albeit a little slowly, but it's going to work. All right, we're finally ready. Let's see if we got this thing. Couple of returns, quick list. All right, let's give this thing a run. What we're doing is all that data that was in the string is getting converted into numerical data right now. It takes a while, and some people need a fidget spinner, so here you go. Okay, you're allowed a quick look at the map. And there you are in the bottom left corner. Take a look. And all goes black and we begin to play. The Dwarven source beam reads 120. And I can only go to the east, so I guess I better go east. And I think I'll go east again. Ooh, now I'm going to head north. Oh. The meter went up. Let's go back south. That reads 100. I'm going to keep going east then in that case. All right. Source beam only reads 90. Let's keep heading that direction. Keep that number down. Not too shabby. Then you get a printout of the maze and where you ended up and found the treasure. Okay, let's put Chem Basic 9 into the machine and get her running here. We'll just go for it per usual. All right, now we'll get a load going. Okay, looks like we're loaded up. Let's take a quick look here. Sure looks okay to me. Let's run it. Looks pretty much the same except for the reverse title up above. And no fidget spinner in Master Hit 1's original conversion. But it also runs a lot faster because you're just reading in 68 elements of data and then you're done. Okay, there's the map. You're a little asterisk in this version. Source beam reads 120, so pretty close by. Let's head east. In fact, it's the exact same game. It hid the treasure in the exact same spot. Hilarious. 18 steps. And it draws a map. Gameplay is identical. So you can make programs that have embedded data in them, and it'll work just fine in Apple I BASIC. Well, as you can see, Apple I BASIC gets the job done if you use these weird string concoctions, slow but functional. So you can make things work in Apple I BASIC. Don't think you're stuck just using Chem 1 Basic 9. There's a lot that you can do with many of these high-level languages. Okay, thanks for watching. Hope you enjoyed yourself, maybe found something useful. If you did, please like this video, and you can subscribe to keep up to date when new stuff comes out. So until we see each other again, take care.